We are live, GM folks. We are coming at you live with the very first DevRel workshop for Movement Labs, Battle of Olympus. So if you're not aware of what Battle Olympus is, it's a really cool hackathon that we've got going on now. And if you try to go and register for it, it might not be too late to go and register. So keep that in mind. But today we're going to be talking a little bit about Move, getting started with the Move language. So this is really geared towards folks who are brand new to Move itself, who I'm kind of talking about it from the perspective a little bit of a Solidity developer. So if you're coming from Solidity into Move, a lot of the analogies and stuff that I use is probably going to be easier for you to understand. But if you're completely new to Move, hopefully this will still be a good way for you to get up to speed and to start building out modules in Move and get your first dApps deployed onto the Movement Labs testnet. We just had a release of our testnet this week, so we're getting pretty slammed on traffic. But yeah, hopefully we start getting some of you guys also developing and building and deploying apps soon as well. I see a lot of people coming into the stream. We're going to give it just maybe a couple more minutes just so we have a bunch of folks in here. If you're in the stream, if you're in YouTube or if you're on Twitter, drop a Gmove in the chat. Would love to know, how many folks are in here. Maybe let us know where you're from, and we'll kind of go from there. And in the background, my daughter has decided to come through. Aisha, can't come in here right now. Give me 1 second while I tend to this. Okay, apologies for that, but I think we've got a bunch more folks in here now. And we'll go ahead and get started. So I'm going to share my screen. We'll go through some slides first, and then we'll talk about going through a little bit of code. So let me present my screen. Okay, so this is Move 021. So like I mentioned, if you're just joining now, I had mentioned earlier that this is Move 0-1, meaning this is kind of like geared towards folks who are like completely new to Move, to the Move language itself. So if you've already been developing on like Aptos or Sui, a lot of this may be very basic to you. You may already be familiar with a lot of the things here. We'll have additional workshops that are geared more to like building full stack dApps and maybe geared more towards your skill level later on. But this is really for beginners and for getting started. So, hey all, my name is Rahat. If you haven't met me before, Senior Developer Relations Engineer at Movement Labs. Formerly been a hip hop artist. I used to stop saying that, but I was told I should say that some more. I don't know. Probably will never rap again publicly, but if you ever want to talk about hip hop, I enjoy going over the old days a little bit there. Used to be a front-end engineer, both in Web 2 and coming into Web 3, did some freelance Solidity development, but now I enjoy building and teaching with Move. So this is the very first educational content piece that we're putting out on the Movement Labs DevRel team. Cool. A bit of an agenda of like what we're going to be going over today. First, just like kind of an overview of movement. We'll talk about the Move virtual machine, the Move language. We're going to deep dive into our first module. It's going to be pretty basic, but I'm going to try to kind of like really break down some of like the different pieces of the Move virtual machine, the Move language itself, and some benefits of it. So I want to just first start off with why the Move VM, why it's worth learning. So some context right now, if you're in the Web3 world, Solidity is the most commonly used smart contract language. Most of the smart contract stacks right now are built on Ethereum or some sort of Ethereum layer 2 built in Solidity. It is, however, prone to attacks. Over 7.6 billion USD in value has been hacked so far from smart contracts built in Solidity. This is just kind of an overview of some of the different types of attack vectors that have affected these contracts. And you can go to DeFi Llama to see updated versions of this as well. Now, I do want to quickly call out that many educators and security experts in the space are helping to improve a lot of this. We have a lot of really, really good educational resources that come out that are helping developers to kind of start building smart contracts with more security in mind. And this is great. This is an awesome way to come in and help people build more secure dApps. But what we wanted to explore is what if we could provide devs with another environment where at least some of these different security issues are thought out from the VM level. So in comes the Move language itself. A little bit of history. The Move language started as a project under the DM/Libra team at Facebook. So this was back at a time when Facebook was exploring how they could build their platform on top of Web3. They could have a blockchain, infrastructure underneath it for payments, etc. Unfortunately, at one point, the SEC said, no, you can't do that. And that eventually, broke out into different teams. We had the Aptos team, SUI teams who have their own chains, and now Movement Labs. So there's a new paradigm here that we're going to be kind of looking into as we code out our very first module, and it's called resource-oriented programming, and we'll dive a bit more into that in a bit. But really, some of the key things here is there's a focus on enhancing the management of digital assets. There's things like support for formal verification of smart contracts as well. And my friend Pratham, who's also on the DevRel team, did recently a workshop around formal verification. So we'll be dropping a link to that later on in the workshop as well. So I mentioned resource-oriented programming, right? What exactly is it? So with resource-oriented programming, there's a focus on managing resources such as memory in a way that's more explicit and controlled. Resources can be things like digital assets, tokens, identities, and there's very, very strict ownership and transfer rules. So resources are moved rather than copied over. So we are going to take a look at how this works practically when we go into the code and build out our very first Hello World smart contract in a second. But overall, what we do at Movement is we're bringing this Move VM, this Move-based L2 onto Ethereum. We're the first Move-based L2 that's dropping. Like I said, we just dropped our testnet, and I'm going to show you a little bit now how you can get started and start building on it today. The easiest way to do all of this is going to be through the Movement CLI. If you go to our docs.movementnetwork.xyz, if you go to the build section and check out Movement CLI, there's the installation instructions here on how to actually go ahead and get this up and running. I've already installed it, so I'm actually going to start building out a Hello World example from scratch. So I'm just going to make a folder. Let's call it Hello Stream. cd into Hello Stream. And sorry, I'm just going to have my cheat sheet on the side. Forgot to kind of pull that up. One moment. Okay. Cool. So if you come from like the Aptos world, a lot of these commands will be very, very similar. You can alternatively use the Aptos CLI instead of the movement CLI if you're like used to that. The only thing to remember is that if you're using the Aptos CLI, you'll have to do a little bit of configuration, make sure that you're pointing to our endpoints, our faucet endpoints, etc. If you're using the movement CLI, you don't have to worry about any of that configuration at all. So a lot of that configuration is just done for you out of the box. So I'm inside of this hello stream directory. I'm going to use this command, movement move init, or actually just movement init first. And it's going to ask if you want to configure, which network. Right now we're going to work on testnet. I'm not going to enter a private key, so it's just going to generate a private key for me. And now I'm going to have an account that is created for me, and it's automatically going to be funded. So if I see here, I can actually pull up this account on the Movement Explorer. So this is my new account that was just made and is automatically funded with one move. Cool. So now I've got that going for me here. Now I'm going to go ahead and set up my environment a little bit further. So I'm going to use this command, movement, pretty similar, movement move init, but I'm going to pass some flags, -- name, and we'll call it hello stream. And now if I do an ls, you'll see that a whole bunch of folders and stuff have been generated for me. I'm going to open that up in VS Code. So now I've got everything set up, ready for me to go. You'll see a .movement folder with a config/YAML, which has like your public key and your private key. I'm never going to use this again, so I don't really care if you have my private key, but if you plan to use these accounts in the future, definitely make sure you don't want to commit these files to GitHub. Cool. So in scripts, this is where you would build out your initial code. So I'm going to create a file inside of scripts, and let's just name that file hello_blockchain.move. Cool. So .move files is essentially where you want to look at building out your module. And let's go ahead and get started with building out the module piece by piece a little bit first. So we'll define module by saying module hello_blockchain and message. So a couple things to understand here. Module, it's similar to how when you build out a Solidity smart contract where you use like the contract keyword. The module is kind of like the smart contract of Move. This hello blockchain is just going to represent what's called like a named address. This is going to be the address where we're deploying this module to, and message is just the name, right? So this is maybe a little bit different from what you might be used to on the Solidity side of things. What we're always doing is that like each of like the smart contracts or modules don't have like their own unique address. They're deployed to a certain account, to a certain address. And so you can have multiple contracts or modules at specific addresses, and they're just identified by different names, etc. So in this case, I've got my message module, and because I don't really want to type every single thing here, I'm going to use my cheat sheet and just copy some stuff over, and we'll explain some of it as we go. So I'm going to import a couple of things from the standard libraries that are available to us. So what are some of these standard libraries? So in Aptos, like the standard libraries that we have is like, these are just like essential utilities for just developing your smart contracts, right? So in Solidity, you might have a lot of these as like built-in functions. You might have some of these as like libraries available from places like OpenZeppelin. But some of these here, so you have like the standard error. This just manages error codes and assertions. We have Signer, which helps us deal with account signers, getting the address. If you're coming from Solidity, this is similar to like the functionality of like message.sender. String, which helps us with like string manipulation and using strings. And then we have this Aptos framework event. This is going to help us with like handling events. So we'll actually go and create like our first event in here too. Now, the thing to like think about in a module, there's two like key components in a module. There are structs and there are functions. So structs represent some data. This is associated to like a resource. So a resource is just some type of allocation to an account where some data exists. In this case, what we're going to do is create a struct that has a message holder. So the message holder itself is just going to be a place where messages can live. So hello world as a message can live at this resource, right? And what you kind of like look at when you're creating these resources, you have this keyword called hasKey. This just allows you to access these resources from like the global state within the chain. So another thing to kind of like understand is that like the module or smart contract itself does not hold the state. The state is held in this global state, and these resources, like let's say this message holder, like this place where this message can live, is attached to an account. So if I interact with this smart contract and create a message, this message lives on the address, on my address, and this resource will be created for me for that. And I'll show you that in action in a little bit, so it might make a little bit more sense. Let's now actually create an event for the creation or changing of a message. We'll just do message change. So for message change, this is going to, track the account or the address which actually changed it, what was the original message, and what was the new message that it was updated to. So this is just an event that we'll see on the Explorer afterwards. We'll also create an error message. So you do that this way. So the way that the error message kind of works, we define a constant with the value of 0. The error code represents like a no message present kind of situation, right? We're assigning a value of 0 just to like help us like easily identify this specific error condition in our code. Cool. So next up, we want to work on some view functions, right? We want to view a message if it exists. So if a message exists, we'll have a function such as this. So we are just like notating that this is a view function. And the way that we define functions in Move, you use this public fun, because functions are fun, messaging here. Then you create your function name and whatever kind of like information it takes. So this get message is going to take an address. And so this maybe will help help you understand like the resource kind of like a paradigm that I was talking about here. We want to get access a specific message at an address. So if I decided to create a message, you need to actually pass my address in here to view the message that I created, right? Because the resource for that message that I created only exists at my account. And any address that other people have created exists in other accounts. So we're not really like creating a message itself that is like uniformly accessible through this module. We're creating a resource of a message that is available at our address. And that's kind of like, it's a little bit hard to kind of like conceptualize. It took me a while to like really get that, but I think as we go through this, it'll get easier to understand that a little bit as well. So cool. We've now got view function, but we want to actually make sure we can set, a message itself. So let's bring in another message for creating that. And that's going to be a set message function. So set message is going to take an account. So whoever's signing the account, and it's going to take a message, which will be just a string, right? And we're going to first check that the message holder exists. So remember, the message holder is like the resource that is allocated here. If it exists, we're going to update that message. Otherwise, we have to make sure that we actually create the message resource itself. So that's kind of like what's happening here. Cool. And you'll see here that we're emitting the event. So this is how you would emit an event for a message change, which was the struct that we had up here. And as we're going through this, it might be new to some folks. If you do have questions, definitely drop them in the stream. I'm happy to, go over anything, re-clarify kind of like anything that we have in here. I wanted to just like re-explain this set message again once more, just to make sure that it fully makes sense. So like the set message function sets or updates a message for your account, right? Either sets it or updates it. So it's first going to retrieve the account address and check, like we said, the message holder, see if the resource exists. And that's where we're using this exists keyword. If it doesn't exist, it's going to create a new message holder and stores it using this move to function. And if you go through just like some of the move documentation, you'll be able to see a lot of these like built-in functionalities that exist. So this is one of those built-in functions. Now, if the resource exists, it's going to emit the message change event, update the message, and ensure that message is, there. And like I said, the reason why we check the resource first, the check prevents like overwriting or like mismanaging of resources. We just want to adhere to like the Move language strict guarantees on like resource safety where these resources are located, and that's exactly what we're doing here. The last thing we can do is really quickly write a test. You can actually drop a test right into the module itself. So I'm going to copy over this test here. And you can notate that it is a test using this here. And essentially what this test function does is really just verifies that a signer can actually set a message, right? Very basic test, nothing too crazy here. Some other things to do, like you can test like further using stuff like formal verification. So Move supports formal verification where developers can like specify different invariants and preconditions that must hold for their specific code, and that kind of just like helps in ensuring that there's an absence of bugs and vulnerabilities, and that helps with like making Move contracts more secure. And I think in the chat, if you're on YouTube, my friend Pratham probably dropped the link for his workshop on formal verification. So that's slightly more advanced than what we'll cover here. So definitely check that out if you want to dive deeper into formal verification on that end. Awesome. So we've now got our very first kind of like Hello World style module or smart contract, however you want to look at it. So let's take a look at actually getting this deployed. So like I mentioned, we're going to be using the Movement CLI on this. Because we use the Movement CLI, we already bootstrapped an account and got it like automatically funded with a little bit of Move. So now what we want to do, one moment, I'm just grabbing the different different commands, as I don't know them off the top of my head. Okay, cool. Let's look at your first, just like compiling and testing the actual smart contract. So if you wanted to compile this, you can use movement move compile and -- named address, and we're going to use hello blockchain equals default, and that's just going to use the default account that we had set up when we first did the initialization. But now we'll be able to actually make sure that our module compiles. And as long as you get like this result here, that means you're good to go. Everything has compiled properly. And now next, let's do our first deployment. So movement, move, publish. And you're going to do similar named address. And then the reason we're using this named addresses flag is because we named, for our contract when we did the module here, the hello blockchain is like this named address. We'll just say that's default. Whoops. Okay. Movement move publish -- named addresses hello _ blockchain equals default. Okay, cool. Yeah, typed it wrong in the beginning. It compiled, so there should be no issues. All right. Yes. Okay, cool. So now it's going to ask if you want to submit a transaction. And let me just hide this real quick. Yes, I want to submit that transaction. The transaction has now been submitted. Cool. And this is the result. You got a transaction hash and all that. But let's actually just pull this up on the Explorer. And you'll see this is the transaction itself. The code has been published. This is the sender, which is just the account that I initially created. So it used like a little bit of gas to actually deploy the module. And I can go to modules and you'll see the Hello Stream module is now available on here. I'm actually going to drop this in the chat for everyone. So you can go ahead and take a look at it if you want to. Cool. So that was a live deployment. On the Explorer, you can do a couple different things. You can run the set message code yourself. You can view, but we're actually going to take a look at doing that from our code. So now I've got all of this kind of like here. I'm going to create a Node.js script that'll help us like actually interact with this smart contract. So let's go ahead and create a folder called Node scripts. I'm going to cd into Node scripts, do an npm init-y, so I can generate like a quick package JSON. And I'm going to install, let's see, I'm going to install the Aptos TypeScript SDK. If you're not familiar with TypeScript, don't worry, I won't really be using much TypeScript at all, or any. So quick thing just to like understand about like the movement test network. Everything is one-to-one compatible with Aptos. So again, if you're coming from the Aptos ecosystem, a lot of this stuff is familiar for you. If you go through the docs, you'll know that there are other environments. Like there's not just an Aptos environment, there's also an EVM environment and a SUI environment. We're not going to go into those too much detail during this workshop, but you can also go into the documentation and build on those environments as well. Our testnet right now, main testnet, supports Aptos, but the other environments also support EVM and SUI if that's where you want to build as well. Cool. So now that I have my script ready to go, let me also just create an index file. All right, index.js. Cool. I'm going to just copy over this quick script that I built out, and we'll go through the script in a second. Okay, cool. So again, this will probably be pretty familiar once again if you're coming from the Aptos world, but I've imported a couple of different things from the Aptos SDK. I'm going to be configuring the SDK to work specifically with our testnet. You can grab these details directly from our documentation. This is available on the build page on the network endpoints. And I've already set up a bunch of things here. I'll drop in like the module address here in a second, but if you recall from the actual contract, there's two main functions, right? There's the set message function and the get message function. The way that you would access each of these functions is first you need the module address, the name of the module, and then the name of the actual function that you want to access, right? So I've set it up this way so that if you at a later point want to test your own module, you just drop in your module address here. In our case, the module address, let's go and grab that. That's available at this account address here. We'll drop that on here. You're going to need to add in like your private key here, whatever private key of an account you want to use to make this transaction. I'm going to just grab the private key of the one account that I generated. Again, private keys are not meant to be shared normally. I'm never going to use this address again, so I don't particularly care about this address, but yeah, that's just a thing to remember. So let's take a look at how we access like the set message. We use our config to actually configure everything. I'm just like console logging a couple things, so like when we run this, we know what's going on. We accessed our private key, and from that we get the account address, and I'll log that out over here as well. And then I'm creating what's called, I call like a payload, a view payload. So this is for viewing the current function. So if the current message, so if the message exists, we'll get the message and display it. Otherwise, we'll also just like submit an actual transaction to set the message function here. And the data here is just the same as the payload. I just wrote it in a couple different ways so you can take a look at it. But the payload is essentially the name of the function, which we defined up here. And then any function arguments that it takes. In this case, it's the actual message that we want to change it to. In the case of viewing the payload, we just want to view it at whatever account address it is located at. And then we sign the transaction. This is how you sign it using the Aptos SDK. And then once the transaction is successful, we'll be able to get the transaction information back. I will log out that response so you can see it. And then we'll read the message again and get the updated new message. Using aptos.view, this is for when you want to like specifically use a view function. Cool. So I will run this in a quick second, but I would love for anyone in the, actually I'll run it myself right now, but if there is a specific message that you want me to update this to, drop that in the comments. I'm going to first update this to Gmove, but it would be really cool to get some crowd participation. Let me know what message you want me to update this to after when I run this transaction a second time. So to actually run this, I'm going to just run the Node script, and something happened here. Okay, yeah, error setting the message. I wonder why I couldn't set the message. So this worked like 10 minutes before I tested everything. But of course, you know, the woes of live coding. Give me 1 second. Let me run it again. Okay, I think it's because we're viewing before anything has actually been set. So I'm actually going to comment out the initial read function. So this is when we do the first transaction. So let's comment this out. Since it doesn't actually exist the first time we read it. Yeah, that was the issue. Cool. So now